Did you know that the global population grew by 74 million people last year alone? That's like adding a country the size of Germany to the global population each year. And even though we gained that many more people, we didn't gain a single hectare more land. And so increasingly we're having to come up with more creative ways to not just improve food security, but improve sustainable food production. And so one of those ways, which is regularly put forward these days, is regenerative agriculture. And while you may have heard of the environmental benefits associated with regenerative agriculture, what about its implications for profitability and drought resilience and greenhouse gas emissions? They're some of the issues that we'll be aiming to address here today. My name is Matthew Harrison. I'm a professor at the Tasmanian Institute of Agriculture, which is part of the University of Tasmania in Launceston, and I'm joined by my colleagues Dr. Ke Liu, Dr. Ranju Chapagain, Dr. Karen Christie-Whitehead, and Professor Caroline Mohammed. We acknowledge funding from the Australian Government Future Drought Fund, as well as many other organisations to conduct this project. We also acknowledge the Palawa, Pakana and Gadigal people, the traditional custodians of the land upon which we live and work. For us in Tasmania, that's Lutruwita. We pay our respects to elders past, present and emerging. Regenerative agriculture is a broad construct underpinned by many component principles. So one of those is cell grazing, which is high intensity grazing conducted for a short period with relatively long spelling periods in between. If you think about wildebeest on the Serengeti, you have a massive herd of wildebeest. They hammer that pasture or grassland for a short period and leave it for several months before they come back to it. So the spelling period is quite high. That's what we're aiming to mimic with regenerative agriculture. It's cell grazing in particular that we'll be talking about in the context of this webinar. But regenerative agriculture also includes a bunch of other component principles, such as silvopastoral systems, which is the integration of trees and livestock on farm, reduced synthetic pesticides and herbicides and fertilizers, high botanical composition or diversity, no cultivation, cover cropping, and a whole bunch of other principles. What we're really aiming to do with regenerative agriculture is to go from a monoculture to a polyculture. So diversity begets diversity, if you like. Diversity improves ecosystems functioning and services. It improves pasture rest periods. So you're resting the pasture for longer before you graze it again. So therefore it's got more time to recover. It aims to improve soil carbon, to reduce soil erosion, to improve landscape hydration. At its heart, what regenerative agriculture is aiming to do is reduce anthropogenic influence on the land and to mimic nature. It's a managed version of chaos, if you like. But there's a lot of questions that remain. And one of those is whether regenerative agriculture improves drought resilience. How does it actually perform in terms of pasture production, live weight gain, and profitability during a drought and after a drought? How do regenerative grazing systems compare with conventional systems? Is it more profitable? What does it do to greenhouse gas emissions? Ideally, we want the sum of the benefits to outweigh the sum of the disadvantages. Otherwise, it's simply not worth it. To give you an analogy, if I have a cold and I have a pill to alleviate the symptoms of that cold, if that pill alleviates the symptoms with minimal side effects, then the sum of the advantages has outweighed the sum of the trade-offs, and so therefore it's worth it. If I have that pill and it alleviates my cold symptoms, but then I die, well, then the sum of the disadvantages have outweighed the sum of the gains. So having the pill in the first place probably wouldn't have been worth it. And exactly the same is true with farming systems practice changes, particularly regenerative agriculture, because it's underpinned by a bunch of component philosophies. And so you're going to get beneficial effects and you're going to get trade-offs. You want the sum of the beneficial effects to outweigh the sum of the detrimental effects. And so with that in mind, the purpose of this project was to examine the effect of regenerative agriculture on drought resilience, so pasture production during drought, as well as climate resilience, farm profitability, and greenhouse gas emissions. We've got particular focus on grazing systems in the context of this webinar. So we've conducted field experiments and we use those field experiments to calibrate systems models and then extrapolate those field results to the long term. So we're contrasting light grazing conducted for a short time with high intensity grazing conducted for for a short time rather, with long spelling periods in between. They're conducted on a real farm at Evandale, which is near the Tasmanian city of Launceston. She is a regenerative agricultural practitioner, so we co-designed the experiments that we'll present here today with her, and part of that includes lack of synthetic fertiliser inputs and lack of other external inputs such as irrigation. We're using the field experiments of pasture biomass, live weight gain and soil carbon to calibrate systems models. The reason for that is we've only got 4 or 5 years of funded trial work. You're subject to the vagaries of the weather. You might get 4 years of very wet conditions, and the purpose of the project is drought. So we're using the field data we measure to ground truth systems models so that we can extrapolate that using 100 years of representative data. We can impose real drought conditions and see how these regenerative systems actually perform under drought in Tasmania, but also other locations. So the models are very good at accounting for soil and climate and management variation. And we can look at alternative variants of regenerative agriculture and contrast that with conventional grazing and cropping systems. We're also looking at the effects of cell grazing or high intensity grazing for a short period with long spelling on greenhouse gas emissions. And the reason for that is regenerative grazing is thought to improve soil carbon, but it could also improve livestock carrying capacity, so you would therefore have more methane emissions per hectare, which might overcompensate the effects of carbon dioxide removals from improved soil organic carbon. Questions are strongly encouraged. Please use the Q&A box down the bottom. We're interested in your thoughts, and I'll hand over to my colleague, Dr. Karen Christie-Whitehead, shortly for a brief poll at the start about who you are, and then another one at the end. There'll also be time for questions at the end. We're aiming for about an hour. It may go longer. It wouldn't be a true webinar without technical issues. So if internet connection is lost, reconnect using the same link. If you can't reconnect, that's the end of the webinar. But I do note that the webinar is being recorded. So if you can't reconnect, you may be able to watch the recording, and the webinar probably will appear online in future. The views of the speakers are their own, and they don't necessarily reflect those of the funding agencies or the institutions with which they're employed. I'll hand over to my colleague, Dr. Karen Christie-Whitehead now for a quick poll about who you are, where you're from, before we hand over to Dr. Ke Liu to hear about some of the progress we've made with the field trials experiments.
Fantastic, Matt. So the first question, and I'll get someone to launch these polls. The first question, we want to really get a best descriptor of what your role is. So you'll see that first question, and there's a bit of a drop-down list where it says select answer. If you go into that cell, you should be able to then, there'll be a drop-down list and select which best describes your role. Now, for some people, they might be a couple of things. They might be an advisor, but also a producer. So select what best represents the role that you have. We'll just wait a few seconds to start to let people select their answers for that particular question. And if you finish that, you can then, there's a slide bar, a vertical slide bar on the right-hand side that's sort of grey coloured. You can then sort of see what that next question is, which is, where are you from? So which state of Australia or territory might you be from? I was remiss in setting up this. I didn't actually put the ACT in. So if you're in the ACT, my apologies. Perhaps you'll put New South Wales as a surrogate for that, or if you're overseas. And then we have a third question, which is a bit of an open-ended question. It's if you are a producer within this webinar today, what's the approximate size of your property, and a bit of an indicator of what your flock or herd size might be. So at sort of point of lambing or calving, you've got sort of 500 breeders or 500 breeders plus 300 young stock. And these questions are pretty much just to get a feel for who's here with us today. And if we have a first look at that first question, what we have a few researchers on the line or within this webinar, a few students and a few of the others. So a bit of a spread across those three groups. If I then move down to the second question, what we can see, we have a lot of Tasmanians here today, and a few others from Queensland, New South Wales, Victoria, and South Australia. So, and one person from overseas, fantastic. And with the third question, we'll look at that data afterwards. So I think thank you for those three poll questions, and we'll have another series of poll questions at the end of the presentations. So for now, I'll pass over to my colleague Ke, and he'll present his slides to you.
Hello guys, can you see my screen? Okay, I think
We
so. Good afternoon, everyone, and thanks for joining us. My name is Ke Liu from the Tasmanian Institute of Agriculture. It's my pleasure to be part of this webinar today and to share the recent progress on our field trials at Avondale. Our trials began in 2024, and they are designed to help answer some practical questions that many farmers are asking. For the first two objectives, we aim to test whether cell grazing improves drought resilience and increases soil carbon sequestration compared with conventional grazing like set stocking. And we are also investigating the feasibility of using drone imagery to estimate pasture biomass. Currently, we are running the trial on a local farm at Avondale with an experienced raging ag practitioner. This trial is co-designed with the farm manager, and we're also using this site to demonstrate results and share learnings with other farmers. To give you some context for the trial, I would like to briefly introduce our case study farmers' farming philosophy. This farm is currently operated by Shelley and Chris. Overall, this farm blends raging ag principles, low input management, and a real commitment to climate action, which makes it an ideal partner farm for our research. Here is the experimental design for our grazing trial. In general, we have 3 treatments, and they are conducted under real commercial farm conditions. These treatments are replicated 3 to 6 times across the whole paddock. All treatments are running without irrigation, fertilizer, or pesticides. The photos on the right, you can see the corresponding stocking rate for each treatment. So specifically, the first treatment is high-density medium spalling, which is also the farm manager's current practice. The stocking rates range between 300 to 800 DSE per hectare, and typically grazing for 5 to 10 days at a time. The second treatment is very high-density long spalling. Here, the stocking rates are 10,000 DSE per hectare, but only grazing for half a day and is done once a year. This treatment is deliberately extreme to test whether very high grazing pressure can create stronger effects on surface organic matter and pasture regrowth. I prepared this video to better show how the very high-density long spalling looks like in practice. As you say, animals are stocked at very high density for a short grazing event, which creates stronger pressure on pasture regrowth and the land. The third treatment is set stocking with a low stocking rate of 8 DSE per hectare, and the grazing up can up to 3 months. Since this is an grazing trial, it's very important to know when to start and stop grazing. There are some rules that we are currently using to evaluate the situation. I won't go into detail here, but we mainly rely on standing pasture biomass, animal gut feel, downschool, and sheep behavior. To answer our questions, we have been collecting a range of measurements. This includes weather data from Launceston Airport, soil physical characteristics, soil carbon, soil moisture, biomass before and after grazing, sheep live weight before and after grazing, feed quality, and drone imagery before and after grazing. Here are the past season weather conditions. We can say both years are a little bit drier than the long-term average. Actually, that's good for our experiment because one of our objectives is to understand drought resilience. So having dry seasons gives us a more realistic test. These are the results of the soil organic carbon change over the past 2 seasons. In the set stocking treatment, we saw an overall loss of soil carbon with an average carbon change of about 1 ton of carbon per hectare per year. Most of that decline happened in the deeper soil layers. In contrast, the very high density long spelling showed a net gain in soil carbon around 3 tons per hectare per year. Those increases are more pronounced in the middle and deeper layers. I think the part of the reason why the for the net increase in soil carbon on the very high density long spanning treatment is because of the intense trampling, which transferred the substantial above ground biomass to the soil surface, enhancing organic matter inputs. Then let's look at the seasonal patterns in soil moisture and temperature for each plot. Blue lines refer to soil moisture, and the red lines show temperature with clear peaks in temperature over summer. Overall, the soil moisture is consistently low across plots. Here is how we measure the pasture biomass on the ground. We use a 50 by 50 centimeter product to mark out the sampling area. Inside the square, all pasture is clipped right down to ground level. For each plot, we collect between 3 and 12 samples depending on the plot size. These samples are dried and weighed, and they could also be used for calibrating and validating the drone-derived biomass or physical models. My colleague Dr. Ranju, will show the relevant results in her presentation later. Here is how the pasture biomass change over time on the 3 grazing treatments. Basically, all the treatments had a low biomass because this farm uses low irrigation and low fertilizer. The good news is that cell grazing generally produced more feed and maintain better pasture condition than stocking. Here we can see the dashed line show the average seasonal pasture biomass. In addition, we have also been exploring how drone-based RGB imaging can estimate pasture biomass. By flying before and after grazing, we can measure changes in pasture cover and the biomass across the whole plot. The RGB images clearly show how grazing reduced green biomass. In the middle maps, red and yellow indicate high biomass, and after grazing, this shifts to blue and green. This box plots show the drone estimate biomass constantly drops after grazing, and that pre-grazing biomass varies widely across the paddock. The drone is clearly detecting both biomass removal and spatial variability, which demonstrates its value for grazing monitoring. So this is one of the advantage because our ground biomass cutting can only sample a few points. So what did we learn from the trial so far? Firstly, cell grazing generally grew more biomass than set stocking, but the results really depend on the soil nitrogen, which determines the pasture regrowth. Secondly, cell grazing is more effective for increasing soil carbon sequestration. And the last, drone imagery can provide accurate pasture biomass estimates. Okay, that's everything from me today, and thank you all for your time and interest. Big thanks to our project partners and founders who make this project possible. Yeah, that's for me. Okay, hand over to you, Ranju.
Hello everyone. My name is Ron. Can you see my screen first?
Got
Just
it.
confirming,
Thanks,
double
Ranju.
checking
Yep.
that before I start. Hello everyone. My name is Ranju Chapagain. I work as a research fellow at the University of Tasmania, and it's a pleasure to have you here in this webinar. So today I'll be talking about the project where I'm leading the systems modeling in simulating long-term economic and environmental implication of region grazing. So first of all, let me start with the purpose of the systems modeling. So the main aim of the systems modeling is to extrapolate the field trial results beyond over time and space with a focus on drought. So with this systems modeling, we extend the field trial results over years and landscapes, which allow us to have a long-term performance comparison, evaluate real-time applicability and real-time risks, which the short-term trials may not be able to capture. So this is the approach we have taken for the modeling. As my colleague Ke mentioned, we have three grazing systems. The first is the self-stocking, the second is the high-density medium spelling, and the third is the high-density long spelling. So the management and the field data for all these three systems, along with the soil properties and characteristics, as well as the future climate, are all input in the model. And from that model, we look into three outputs which farmers are more interested in. First is how well the pasture grows. Second, how profitable the farm is. And third, how much is the emissions. So let me quickly present some of the initial model performance results. So this plot presents the annual pasture production across the three grazing systems. The pink bar represents the experimental values, whereas the blue bar represents the model value. The error bar represents the variability across the replicates. So overall, the model can satisfactorily reproduce the actual observed biomass, trend, and magnitude, even for before grazing and after grazing. And like my colleague Ke mentioned, that during 2025, we had less rainfall as compared to the 2024 season, which is clearly replicated in this plot. So in terms of when we compare the average daily life weight gain across the plots, what we found was the model was satisfactorily able to reproduce what was observed in the field in terms of average daily life weight gain. So the pink bar represents the experimental measured value, whereas the blue bar represents the model value. And during the grazing event that occurred during March and May of this year, there was almost no live weight gain during that grazing event, which the model was successfully able to capture as well. So because the results align closely with what was measured in the field, we use this model as a tool to test various what-if scenarios of grazing without taking the actual risks. So here we conducted a scenario analysis building on the field trial results, where we compared the different grazing systems under a constant grazing pressure. For reference, we have taken 1000 DAC days per hectare. So each of these grazing systems vary in grazing duration as well as the rest period. So by doing this, it allows us to have a fair comparison and make sure we are comparing apples and apples and not apples and oranges. So having the three systems set under the same grazing pressure, it allows us to have a fair comparison in terms of profitability, feed supply, as well as the emission across the three systems. Let me quickly talk about what are the three systems we modeled. So trying to replicate what we did in field, we are testing three different systems, which is high density long spelling, where the stock graze in a paddock for a single day and the paddock is rested for 364 days. Second is the high density medium spelling, where the animals are grazed in the paddock for 3 months and the paddock is raised for remaining 9 months. And third is the set stocking treatment, where grazing occurs between alternate paddock each month. So each of the systems have the same soil type, same climate, as well as the same weather on the system in the scenario analysis, but they just vary in terms of the grazing regime. So before I present the results, I would quickly like to flag that these are just the preliminary results and are based on weather on a system and as well as the current version of the model we are using. And we are continually working towards fine-tuning the model as well as doing additional analysis for the scenario analysis. So talking about greenhouse gas emission intensity, this graph represents the greenhouse gas emission intensity across the three systems. The orange bar represents the greenhouse gas emissions from wool, whereas the blue bar represents the sheep meat emission intensity. So what we observe from our analysis is that the high density medium spelling, where the plot was grazed for 3 months and rested for the remaining 9 months, it resulted in low emission as compared to the other two systems. And this graph represents the concentration of soil organic carbon, which we modeled across a period of 100 years. The red lines represent the high intensity long spelling system, whereas the green line represents the high intensity medium spelling, and the blue line represents the set stocking system. So what we found from our analysis that as compared to the other two, the increase in the concentration of soil organic carbon is lesser for the set stocking treatment, though over a period of 100 years, the difference is marginal. So talking about profitability, we instead of taking average value, we took a range of possible scenarios and then run the economic analysis. And what we found was, as compared to the other two, high density medium spelling was more profitable uh, than the other two systems. So this graph represents the annual pasture production for average drought and post-drought years over a long-term period. The red bars represent the high-density long spelling, the green bar represents the high-density medium spelling, and the blue bar represents the set stocking treatment. What we observed was, if we look into the three system, the high-density medium spelling has the best comeback. It performs well in terms of it um, it has a high pasture production during average year, uh, less reduction in pasture production during drought year, and comes back strongly after a drought year as compared to the high density medium spelling and the set stocking treatment. So what actually happens on the ground when there is a drought year? So we looked into 2015, which was a drought year, and compared that with what happened in 2014, and see what does drought do in terms of profitability, production, and emissions. So the green pasture year represents the pasture production, the money bank represents the profitability, and the ship with the cloud represents the emission intensity. So what we observed was, though during drought there is a decrease in pasture production across all the three systems, and there's a slight increase in profit due to the increase in market price, what we observe was overall high density medium spelling offered the best results. So there is less reduction in pasture production, slightly more increase in profitability as compared to the other two systems, as well as slight reduction in intensity as compared to the other two systems. So here are the concluding remarks for the work we have done till date. So the model is successfully able to capture what is measured in the field in terms of pasture biomass as well as the average live weight gain. So in terms of soil grazing pressure with equal grazing pressure, soil organic carbon dynamics are generally dominated by long-term soil carbon rather than grazing timing, so which has resulted in near identical concentration of soil organic carbon trajectories. And The key message we found from the analysis of emission intensity, profitability, soil organic carbon, as well as the pasture production is high density medium spelling strikes the best when it comes to having a balance between pasture resilience, profitability, and emissions. So here's the takeaway to date from the initial results that we have. So for this site, grazing region matters less than we think. It is the grazing pressure that makes or dictates profitability, soil organ carbon sequestration, and the emission intensities. Thank you everyone for listening to my presentation, and thank you to all the funders and the project partners for this project. Now I'd like to hand over to Karen for the poll.
Thanks, Ranju. And similar to what we had at the start, we've got a series of questions coming up on your screen now. The first question is, overall, how would you rate the session today? And if you click on in the box there, there should be an ability to rank how you rate the session today. The second, okay, I seem to be seeing questions that are related to another webinar, because the second question, if everyone else is seeing the same thing as I'm seeing, is the increase your knowledge of nitrogen efficiency in dairy systems.
Well, it wouldn't be a true webinar if we didn't have technical issues. People can use their imagination with that one.
So I guess, yes, select an answer. We'll just surrogate or swap over the knowledge of nitrogen efficiency in dairy systems with about regenerative agriculture grazing systems. And yeah, has your knowledge increased being present at the webinar today? And yeah, is there any other information or questions that you would like us to look at? Is what the third question is really targeting at. I'll give you everyone a few minutes to respond to those questions. Okay, so we're starting to see some of the responses now come through. So this first question was, how did you rate the session today? Most people have rated it sort of very good or even excellent. There's a few people that said fair, which is fantastic. Has the webinar increased our knowledge of regen ag? Hopefully you've answered this in the context of what today's presentation is, not in the context of nitrogen efficiency in dairy systems. And we've got a sort of almost a 50-50 split there. And then the third question is, they will be, because they're open-ended, we can't see those answers. So I'll thank you everyone for filling in those poll questions, and now we'll move to the Q&A session. So I'll hand back to Matthew for those.
Thanks, Karen. I'm just starting from the top. Someone anonymous said, have you got, and I think this question came up before you got to it, Ranju, have you got any economic data on the set stocking versus cell grazing? You did have, and you did present that. Can you remember what that was?
Yes, I did have the data in which I presented it. So basically, we have taken the long-term data from average data set. So it's not an average, but We just wanted to simplify this analysis, but we did a proper Monte Carlo simulation using triangular distribution where we have taken into income from wool, cost of different cost in terms of minimum, maximum. So we haven't taken average value for the economic analysis, but we have looked into a series of medium, high, and more values while doing the analysis, which I have presented just now.
Yeah, I guess the take home for me was that box plot that Ranju had near the end, where she segregated the effects of grazing treatment in a drought and the effects of the rotational grazing or high intensity short-term grazing with longer spelling stood out as more productive, more profitable during a drought. Now, these are early results, but they might change in future. But that at this stage is prospective, at least to me, at least. The second question there from Aussie is, which is a good question, Ranju. Did the emissions intensity take into account the increase in soil organic carbon, or was it only on the basis of yield turnoff?
And no, we did take into account both, including sequestration and excluding the sequestration. So the result I present was excluding the carbon sequestration, but we did look into the soil organic carbon sequestration effect on the emission intensity as well, which showed similar results. I mean, they obviously the process numbers would decrease when we take the soil carbon sequestration effect. So we have looked into that, and that decreases the number. But the plot I presented, or the result I presented, didn't take was without the sequestration effect in the emission intensity. But we have looked into the sequestration emission intensity without the sequestration as well.
So the big question, Ranju, is by how much does the soil carbon influence the emissions intensity? Is it a big chunk, minor, or intermediate, if you recall?
Intermediate, actually,
Okay.
because it boils down to how much is captured. So based on the soil carbon sequestration, it has an intermediate immediate like middle effect, not very high, not very low, but we have looked into that, and it does reduces the emission intensity when we take into account the carbon sequestration.
This research is ongoing, by the way. So we have shown in the past that a lot of the gain in soil carbon depends on where you start from. So if you start from a low base, like a degraded system, then your potential to gain soil carbon is quite high. Whereas if you're starting off from a well-maintained soil over the last 100 years, then your potential to gain soil carbon is pretty low. You can't gain soil carbon infinitely from plant carbon inputs. You can if you bring in compost, but not from plant growth. So a lot of the gain in soil carbon from any practice change depends on where you start from. So that needs to be taken into account. Can you please explain a little more about the high density medium spelling scenario, why it was more profitable, and was there a difference in and why if there was less biomass production for that system?
Okay, to answer that question, yes, the high density long spelling had slightly higher biomass as compared to the high density medium spelling. But then what we need to take into account that in high density long spelling, the animals are like in very, very high density in that particular plot, right? So it definitely boils down to how much they're intaking, how much passages they intake, how much weight they gain when they are moving across plots each day, because they are in high density each day in each of the plots, and how much fleece weight they are gaining. So what we observed was, because the animals got to sit there in for 3 months and then they are moved to another paddock for the high density medium spelling, they had enough time to gain, they had good fleece weight gain and life weight gain compared to the set stocking, where although you're moving between the paddocks alternately, the pasture don't get enough time to recover, and then you have the other high density low spelling where there's enough biomass, but the animals are in so high density that more than one third is trampled upon, and just one third is eaten and one third is left, right? So it boils down upon like how we have developed the grazing system and how much they're intaking, so how much they're gaining and in terms of fleece weight and life weight. So that's why, rather, although they have like high biomass production for the high density low spelling, but it depends on like the intake and the live weight gain and the fleece weight gain compared to the live weight.
Thanks, Ranju. Graham has asked a question. It was great to see the ultra high stock density. It'd be great to see how it goes over the duration of the project. Are you also measuring landscape function vis-a-vis Tongwei et al. 2004? The short answer to that is no, Graham. Very good question. We have noted that, though, your comment, and probably will look into that Tongwei et al. Publication. So thanks for that. There was a question there that I skipped, which is also a good one. Are you taking into account labour, Ranju, in the effect of profitability?
Yes, we have, because see, in terms of high density long spelling also, we have also taken into account that because the stocks are moving every day, the diesel or the fuel use would be more as compared to the other two systems. So we've tried to take into account different factors that play into account while having this grazing regime. So yes, we have, and all of these results are presented in terms of dollars gained per head per annum. So yes, we have taken into the labor costs, sharing costs, and diesel costs for each of the system based on how they are managed.
Thanks, Ranju. I'm going to go to a few questions for Ke now. Some of these have already been addressed, but I think it's useful for the other people if we briefly go over them. And Ke, you've already answered them. Bianca asked, how long do you think the carbon will reside in the soil, which is a good question. Ke?
Yeah. Yeah, I reckon from years to years, but it really depends on the agriculture management. Because we know good practice will definitely help restore soil carbon, but bad practice will accelerate the soil carbon loss.
Yeah, so I can add to that. A lot depends on, and carbon markets have this thing called permanence. And the implicit in that is that your practice change, in this case, regenerative agriculture, is permanent. So as soon as you change that and you go back to a conventional system that degrades the pasture production or ground cover over summer when it's not growing, your soil carbon will probably fall. Soil carbon does go down in drought, but if you can maintain that sustainable management practice, it does go up over the long term. And Bianca, being a soil scientist, will probably already know that you have your labile stuff or your particulate organic carbon, which cycles very fast. So it comes and goes seasonally. And then you have your more recalcitrant soil carbon pool, which is known as mineral associated organic carbon, which is bound to the clay particles and is thought to be more permanent. So it resides there much longer. We are looking at soil carbon fractions in Ke's measurements. We just looked at total soil organic carbon in those numbers he reported. But we will see, and it will be interesting to note whether there's differences between particulate organic carbon, the labile stuff, and recalcitrant organic carbon. So hopefully that addresses your question, Bianca. Sophie Steele asked a question, how did you sample and test soil carbon, Ke? What depth, how many samples, and were they individual or composite, and what testing method?
We didn't sample the soil by ourselves, but we used the sampling service provided by Farm Lab. This is a very professional company which can help us measure the sample the soil and measure the soil properties. The soil depth is we have three soil depths from 0 to 10 centimeter, 10 to 30, and 30 to 60. Yeah.
Thanks, Ke. That actually follows the 2021 Australian Government Soil Carbon Method. So that's separated into strata and then a number of samples within strata, I think. But we can provide more on that after if you want, Sophie. Someone else asked, how long were the pasture recovery times, Ke, that you were using for the 2 cell grazing trials?
We have 2 cell grazing treatment. For our very high grazing treatment, the rest period will be up to 1 year. The other one is our farm manager's practice, yearly between 4 and 5 months. Yeah.
Thanks, Ke. Another question. I'm just wondering, Ranju, what model you used for doing your modelling?
Sorry about that. We tried to keep it simple because we were targeting a general audience. So for the biophysical modeling, so that is for the pasture production and the life weight gain and the fleece weight and everything, we have taken UpSim. So UpSim, along with the crop modeling, you have like models in UpSim where you can do grazing systems as well. So in terms of economic modeling, we have used Monte Carlo simulations. And for the emissions part, we have used something called SPGAF, where you can look into the seasonal emissions, and that gives you the emissions across the total emissions as well as the emission intensity for wool and sheep.
Thanks, Ranju. Another question there for Ke. Ke mentioned that soil nitrogen was critical for determining pasture regrowth. Are you adding nitrogen in the treatments?
Actually, no. I prepared another slide so I can give a very quick about the overview. So this is our baseline soil sampling. We measured the nitrogen to so you can see there is a lot of variance across plots. So some plots have the higher, some plots lower, and once the grazing, the plots with the higher nitrogen will grow faster. So that's why I say that soil nitrogen level is a really critical factor.
So our stratification is designed to pick up that effect of existing or implicit soil nitrogen variability. On the question about are you adding nitrogen, we're not adding nitrogen because we're fitting in these treatments with the regenerative agriculture practitioner, Shelley Saunders-Cocker, and she's actually on the line today. So we designed to make these treatments congruent with her farming system. Another question was, did the emissions intensity? I've already asked that one. I think that might be just about it. Open questions. How do you account for grazing for a set time given pasture growth isn't linear? That one's for you, Ke.
Sorry?
How do you account for grazing at a set time given pasture growth isn't linear? You actually have 4 termination
Yes.
criteria.
The standing pasture biomass is just one of our criteria to evaluate. We also have other 3 like the animal gut feel, dung score, and behavior. So any of these, if any of that not meet the criteria, we stop grazing. Yeah.
And it's a really good question because, it's difficult. You've got replicates of each plot, and obviously different plots are starting at different biomass when you start to graze them. And so therefore you can't necessarily graze them all for the same duration. You have to have different termination criteria as long as they're standardized across plots and across treatments. And so that's why we've got the 4 termination criteria. Not easy in a grazing systems experiment though. Another question, which is a really good one, really pertinent, which we didn't address here, which is highly topical though, is biosecurity. So what about the differences in animal health? For example, worm burden between grazing treatments. Not sure whether Shelley can talk or not, but we didn't really assess that. My view would be that if you leave them on there for too long, their manure builds up and the pasture goes down and there's a risk that they consume their own manure, and that's when the worm burden goes up. If your residual pasture biomass is enough so that their mouths don't get too close to ground level, then the risk of them consuming manure and therefore worm burden is less. There are other animal experts on the line, but happy if that person wants to send an email later and we can dig into that one further. One final question, further on the soil nitrogen question. So the long recovery had higher soil N and grew more pasture. Do you get that question, Ke?
Yes. Yeah. I think you're right.
Yeah, so the question was, so long recovery had higher soil nitrogen. Yes, Ke suggests that it's growing more pasture. And the way we're capturing that is through multiple replicates.
Yeah.
That is, I think, about it. I've probably jumped the queue there unless I've forgotten anything. No one is waving at me. If not, thank you very much for attending. Thanks for your interest. This will be online at some future stage, and thanks for attending.